All right, here we are, quarter 4, week 2, day 2. Find the quotient. And again, we like to do this. If there's ever a multiplication sign there, we can skip a step, right? But remember, if there's division, we have to keep, change, flip. So we have 4 over 7. And then we change the division sign to a multiplication sign and flip this. That's called the reciprocal or the multiplicative inverse. Okay, so at this point, we can see if we can cross-reduce anything. Is there anything that goes into both 7 and 5? Nope. How about 4 and 1? Nope. So we're just going to have to do what we got. 4 times 5 is 20. 1 times 7 is 7. How many times does 7 go into 20 without going over? 2 times. All right, so we've used up 14 of the 20. So we have 6 left over in the numerator out of 7. So the answer is 2 and 6/7. There's the quotient. What is 88% of 50? Okay, so it's the majority of 50. Okay, so it's going to be over half of it. So 25 is half of 50. 88% is going to be more than 25. So we're going to have to make sure that we get that type of answer. So 88%, remember, 88% could also be written as 0.88 or 88 over 100. Remember, percent means out of 100. So 88%, 0.88, and 88 over 100 are exactly the same amount. All right, so which one's going to help us the most? Well, let's see. We can do 0.88 of means times. So when you see a mathematical equation like this, so we can just do 0.88 times 50, and that'll give us our answer. Or we can do 88 over 100 times 50, and that'll give our answer. So let's see if we can do this, and I think it might be pretty easy. Because what can we do? Can we cross-reduce anything? Yeah, we can. We definitely can. So we can do 50 into 50 and get 1, 50 into 100 and get 2. Okay, and there's that answer. And as a matter of fact, this 88 over 2 can be reduced because I can divide 2 into 2 and get 1, and 2 into 88 and get 44. So now we just have 44 and a bunch of 1s, because 44 times 1 is 44. 1 times 1 is 1. So the answer is 44 over 1, which is 44 out of, well, 44. So 88% is 44 out of 50. So there's our answer. Okay, we could have gotten it several different ways, but that's a pretty easy one, especially since we can cross-reduce the 100 and the 50. That made it really simple. All right, let's move on to the next one. Evaluate the expression. Okay, there is a lot happening here. First of all, we have these parentheses, and then we have the parentheses inside those parentheses right here. So let's go ahead and start working this out. So the first thing we're going to have to do is inside the big parentheses, and then since there's parentheses in there, we have to do that first. 4 plus 3 is 7. So then we end up with 12 plus 8 times 7 plus 2 minus 6. So we have to keep working inside the parentheses here. The next thing we have to do is multiplication, right? So 8 times 7 is 56. And actually, let's go ahead and just add the 2 to help us skip a step a little bit because it's all in the parentheses. 56 plus 2 is 58. All right, so we're done with all the parentheses. So now we're left with 12 plus 58 minus 6. So now we just do left to right. We have 12 plus 58, and that equals 70. So we have 70 minus 6. Then we subtract that 6, and we are left with 64. Okay, 64 is our answer when we follow the order of operations and evaluate the expression. All right, now we're going to find the area of this kind of sideways looking church or interesting witch hat. I don't even know. So let's see. Probably the easiest way to divide this up is just make the triangle and the rectangle. All right, so let's go ahead and solve this then. So the rectangle is 9 by 12, right? So to find the area of that is just 12 times 9, and that equals 108. So this rectangle is 108 centimeters squared. Now we have to find the triangle. Well, the triangle is not quite as easy, okay, but we know that this is 3 and this is 3. We know the whole distance is 12. So if we take 12 minus 3 and then another minus 3, well, 3 and 3 is 6. So 12 minus 6 is 6. So the distance across here is 6, right? And then we have to have the height of the triangle. Well, this whole distance from here all the way up to here is 15. Okay, but we know that this distance is 9. So you're going to do 15 minus 9, and that's going to give us 6. So we also know that the height is 6. So the base is 6, and the height is 6. Doesn't really look right proportionally, but that's our answer. Okay, so let's do it. 6 times 6 is 36. But it's a triangle, so 36 divided by 2. So this triangle right here is 18. So to find the entire area, you're going to do 18 plus 108, and that give you 126 centimeters, and its area, centimeters squared. 126 centimeters squared. Find the surface area, which means we need to find the area of this base, right? And then this triangle over here, the triangle in the back, and the triangle over here, right? So we need to find the surface area of all of those. I went ahead and drew a net right over here. So let's find the base. The base is 7 times 7. What is 7 times 7? 49. So the base of the square pyramid is 49 centimeters squared. The triangle, though, is 7 by 12. Okay, so 12 times 7 is 84. But remember, it's not the area of a triangle. It's the area of kind of a rectangle. So you have to divide that by 2, and that's going to be 42. So this triangle is 42. Now let's look at this. The base is still 7. The height looks like it's the same. The base over here is still 7. The height is the same. So every single triangle is going to be 42. Okay, so to find the surface area of the whole thing, you're just going to do 42. Well, let's do a shortcut. 42 times 4, and that's 168, plus 49, that equals 217 centimeters. Surface area is centimeters squared. Yes, 217 centimeters squared. Graph the integer 6 and its opposite on the number line. Remember, integer means a positive or a negative number, and it can include 0, but does not have a decimal or a fraction. So let's go ahead and just plot the 6. Okay, and what would be the opposite of the 6? Well, you would go through 0. Okay, and you would go exactly the same distance through 0 to the other side. So here's 0. You go the same distance away. There it is. So now we have graphed the integer 6 and its opposite. Here's 6. Here's its opposite. That's all there is to that one. Place the number 3.4 on the number line. Well, here's 3 and here's 4. Okay, so this number line is basically just the distance between the number 3 and 4. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is actually going to be 3.1. And this is going to be 3.2. And then 0.3. And then all the rest of them. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. And now we're at 4. So between 3 and 4 is 3.1, 3.2, 3.3, and so on. All right, so to graph 3.4, we just go to 3.4 and put the dot right there. That's all you have to do. 3.4 would be the 4th tenth. Okay, it's broken into tenths, and it's the 4th one in. So that's where you would put your dot plot, or your dot. Graph the ordered pair 3, 5, and its reflection. Okay, reflection is kind of like looking in the mirror, right? If you get closer to the mirror, you get closer to your own face, right? If you get further away from the mirror, you get further away from your own face. So that's kind of how reflection works. So let's go ahead and graph the 3, 5. Okay, so we're going to start right here at the origin. Okay, we're going to start right there. And we're going to go 3, 5. Well, you always go across the x-axis first. So we're going to go 1, 2, 3. So it's going to be right around there where I put the little dot. Okay, and then the 5 goes up and down on the y-axis. So we went over 3, then we have to go up 5. If it said -5, we would go down 5, but we go up 5. 1, 2, 3, 4, 5, which would end up being our plot right there. All right, so that is 3, 5. All right, so at this point, they want us to do the reflection over the y-axis. Okay, so here's the y-axis, the one straight up and down. So if we want to do the reflection across that, we need to go the same distance on the other side of the y line, of the y-axis. So there's 1, 2, 3 places, right? So we're going to have to go 1, 2, 3 places over that direction, and then we would plot it right there. So there we go. That's our reflection. What if they asked us to reflect it over the x-axis? Well, then you would go 1, 2, 3, 4, 5 down, and then you go 1, 2, 3, 4, 5 more and put it right there. Okay, but they didn't ask us to do that. They asked for the reflection over the y-axis. So there we go. There's our original plot, and here's our reflection. Okay? All right, let's go on to the next one. Graph the ordered pair 5, -2. So the 5 is going to go across the x-axis. Okay, and the -2 is going to go on the y-axis. Okay, up and down this direction. All right, so let's go ahead and graph it. Let's do that real quick. All right, so we're going to go a +5. So again, we start right here at the origin, and we're going to go in a +5. 1, 2, 3, 4, 5, which would be right there where I put the little dot. Then we go -2. So should we go up or down 2? Well, if it's -2, we're going to go down. So we're going to start there, add our little dot, and go 1, 2, down. All right, and we can go ahead and plot that right there. Okay, so that is 5, -2. We went over 5 and down 2 because it's -2. Okay, so then we need to find the reflection, once again, reflecting across a mirror over the y-axis. Okay, so once again, we're going to go across this axis. If they said across the x-axis, we would go up and down this direction, right? Okay, but they don't want that one. They want to go across the y-axis. Okay, so we have, right here, we are 1, 2, 3, 4, 5 away from the y-axis. So we have to go 1, 2, 3, 4, 5 away on the other direction, and that's where we would plot the reflection. Okay, so the reflection is, or this is the original one, okay, and this is where we plot the reflection, which is exactly the same distance from the y-axis, because that's kind of what we used as our mirror or our reflection. Okay, there we go. That's our answer for that one.